So this is probably the trickiest question that we've had to do so far. And I guess what makes it tricky is that there's no real indication in the question which of the techniques that we need to learn, that we've learnt of, we need to actually use to answer the question. Let's have a read. It says an injured bushwalker is located at a position relative to a camp given by the vector 2i plus 3j. Okay, so we could draw that in. 2i plus 3j, and right now this is where the bushwalker is located relative to the camp. Okay, so I'm going to let A be the bushwalker's position. Okay, and that's going to be a distance from the camp. We don't know where he is. All right. We know that a searcher heads off from the camp on a road parallel to some vector. So that vector is 3i plus 4j, and we can sketch that as well. Okay, so we're going to let B be the position of the searcher. But we don't know how far along B he is. Remember, if a vector is parallel to another vector, it's some multiple of that vector. Okay, so the word parallel there tells me that we don't know how far along B the searcher has gone. All right, so we've got that A is 2i plus 3j, and B will be some multiple of 3i plus 4j. All right, and what they're asking us to do is to determine how far the searcher is from camp when closest to the bushwalker. Now, hopefully you can think about just a logical explanation of the fact that when you're closest to something, it is the perpendicular distance from someone else, okay, or from something else. So what they're telling us, without telling us, okay, is that we need to find the vector projection and the scalar projection, okay, because the scalar projection is going to tell us the distance that the searcher is from the camp when he's closest to the bushwalker, because at that point we would be able to find the perpendicular component of our vector projection, and that would give us how far away he is from the hiker. That sounds really weird. But let's draw our little torch perpendicular to B. And what we're looking for, okay, is firstly, how much of A is shining onto B, so the distance that the searcher is away from camp when he is closest to the injured hiker. And the point that he's closest to the injured hiker is going to be that perpendicular distance there. All right. So let's have a look. The first thing we need to do before we can find any of those perpendicular and any of those vector resolutes or vector projections, we need to find the scalar projection of A onto B. And in order to do that, we need the magnitude of B and the unit vector in the direction of B. So our magnitude of B is going to be square root of x squared plus y squared, and that would be the square root of 3k squared plus 4k squared, and that becomes 25k squared, which is 5k. Don't let that k worry you. You'll see in a minute that it is not an issue. Then our unit vector in the direction of b is just going to be b divided by my magnitude of b, and that means I've got k times 3i plus 4j divided by 5k. Isn't that wonderful? The k's cancel. So basically with our unit vector, because its magnitude's 1, it doesn't actually make a difference what your k value would have been. And so we have 3 over 5i plus 4 over 5j. So therefore, the scalar projection of A on B is going to be A dotted with my unit vector B. And now we have, this is x1, y1, this is x2, y2. So we're going to have 2 times 3/5 plus 3 times 4/5, and that's 6/5 plus 12/5, and that gives me 18/5. Okay, so that is my scalar projection. That's not giving me anything in terms of the vector projection, which is the magnitude and direction of my searcher. Okay, in order to do that, I need to create or multiply my scalar projection, that's just a scalar number, by that unit vector in the direction of B, so that it can become a vector projection. I can't find a magnitude without having a vector. Okay, so the first thing I'm going to find is a parallel, which is my scalar projection, multiplied by my unit vector, and that's my 18 on 5, multiplied by 3/5 I plus 4/5 j, and that gives me 54 over 25 I plus 72 over 25 j. So this is my vector parallel to A, okay, or A parallel, my vector projection of A on B. And once we've got it into a vector form, we can find our magnitude of it. And our magnitude of A parallel is going to be my square root of x squared plus y squared, and that would be my square root of 54 over 25 squared plus 72 over 25 squared. That's a really big number. Use my calculator, and that's 3.6 kilometers. Okay, so what does that mean? That means that the searcher has traveled 3.6 kilometers along B to get to the point where he is closest to the hiker. Okay, so what we have there is we're now wanting to try and find how close he is to that hiker. So we're looking for this little A perpendicular. Okay, and to do that, we're going to need to use vector addition or subtraction. And we can say, so this vector that I've got in red here is my A parallel. All right, so I'm going from my searcher to my hiker will be minus A parallel plus A, or A minus A parallel, and we call that A perpendicular. So A perpendicular is A minus A parallel, and my A was 2I plus 3J. And we're going to minus 54 over 25I plus 72 over 25J. And our vector A parallel is negative 4 over 25I plus 3 over 25J. Okay, so that's the vector A perpendicular. It's not the magnitude of the vector, which gives us how far. So our magnitude of A parallel is going to be magnitude is our square root of x squared plus y squared, and that's going to be negative 4 over 25 squared, that's a 5, plus 3 over 25 squared, and that value is 0.2 kilometers. Okay, so what I've done is I've found a vector along B or parallel to B and found the magnitude of it, and then I found the vector that is perpendicular to B and found the magnitude of that. So therefore the searcher is 3.6 kilometers along the path when he is 200 meters from